All right, guys, welcome to Lab 14 for week 14. This lab is going to be a long one because not only is it going to be a couple of new little things, but it's also going to be a review for your coming test for 171. All right, so let's get into it. The first thing that we're going to talk about are exponential functions and where they are utilized. But the first thing that we're going to go over is actually the types of exponential functions. So the one that we tend to use is when we use compounding continuously. So we have compound continuously. All right, and we use A equals P times 1 plus the rate raised to the power of time. All right, so P is the starting value, R is the rate, T is the time. When we are talking about compounding interest, but in intervals. So we have compound interest. We'll use an interval of time, intervals. So that's when we use A equals P times 1 plus R over N, right? That's the number of months, raised to the power of T times N. Again, this is like if it was quarterly, yearly, or not yearly. Yearly is actually whenever we use just the top one. That's yearly. When we're talking about monthly, bi-monthly, whatever it might be. The next one we have is just exponential growth. Well, exponential, which obviously you guys should be pretty familiar with at this point. We use A equals P times E raised to the power of RT. P is the starting value, R is still the rate, T is still the time. Remember, we always convert the rate from a percent into a decimal. Number one thing, always convert percent into a decimal. Okay, so looking at number 1, it says solve each exponential problem. We're going to show all of our work for each problem. It says, suppose that $10,000 is invested at an interest rate of 5.4% per year, and it is compounded continuously. That little part right there is going to tell us exactly which one we're going to use. We're going to use our first one, P times 1 plus R to the power of T. It says, find the exponential function that describes the amount. Okay, well, that's easy. We just set it up, right? So I don't have any space to the side, so I'm actually going to write it above it. So we know that A is equal to my starting value. Well, that's my investment of 10,000. Times 1 plus, remember, convert that 5.4%. The decimal is actually moved over 2 spaces to the left so that it's 0.054. So we plug it in as 0.054. And we're not given any time, so we raise that to the power of T. That's our formula. We insert our time and we get our value. All right, it says, what is the balance for 1 year, 2 year, 5 year, 10 year? Well, I'm going to go to my calculator and I'm going to go into y equals. All right, and I'm going to go, oh, hang on, guys. There it goes. Okay, I'm going to go into y equals, and I'm going to plug in 10,000. Oops, hang on, let me just clear that out. 10,000 times 1 plus 0.054, close the parentheses, and raise it to the power of T. Well, we don't have T in our calculator, so we just change it to X, because that's what we're going to input, and the Y is what is going to be our output. So I plug it in, and I'm going to hit second graph so that I can see my table, right? And it says, what is the balance at 1 year? Well, at 1, our value is going to be $10,540. All right, so year 1, we have $10,540. Go back to my calculator. And then it says year 2, well, I have $11,109. And then we're going to go down to the 5 year because that's what it asked us for. So see the 5, and it's 13,008. Whoops, I went past it. So 5 is 13,008. So I'm going to, again, $13,008. And of course, at 10 years, let me open my calculator back up. I'm going to go down to 10. I get 16,920. So 16,920. Whenever you're writing this down for your test, by the way, please note like 1 year equals, 2 years equals. That way nobody gets confused. I just ran out of space, so I'm using what I've got. Now it says, what is the doubling time? All right, that means how long will it take for you to reach $20,000? So where in my equation do I plug that in? Well, that's our A. We're saying we want to know, where does our equation equal $20,000? I'm going to 1 plus 0.54. Okay. Raised to the power of t. Okay, there are 2 ways I can go about doing this. If I'm estimating, well, then I'm going to use my calculator. So if I'm estimating, I'm going to go into my calculator and I'm going to look for where I start seeing $20,000. Between 13 and 14. If I look at 14, it's over 20,000. So it has to be between 13 and 14 years. So we're going to say approximately 13 years. But if your instructor wants you to be specific, well, then we have to actually do the math. In order to do that, I'm going to actually go to the side. Now, the easy thing is, anytime you see doubling, we know that it's where everything doubles, so it's just 2, equals my percentage, 1.054, raised to the power of t. Now, if you are one of those, you're like, where did I do that? Well, I'm technically dividing both sides by that 10,000. Sorry, 10, 1, 2, 3. I'm dividing both sides by 10,000, and that's where I end up getting that 2. All right, so I'm looking for that, and what I have to do is I have to take the log of both sides, so that I get log 2 is equal to log 1.054 raised to the power of t. I take the log of both sides so that the t can move to the front by the exponential rule. So that t moves to the front, and he's gone. And then I divide both sides by log 1.054. 1.054. And then we're going to go into our calculator. And we're going to go into the calculation portion. So we're going to hit second quit to get us out of everything. All right, and we're going to do log 2 divided by log 1.054. Close the parentheses, hit enter, and we actually get 13.179. Remember, if we're doing the exact, right, we want 3 decimal places, so 13.179, that 5 rounds that 9, which of course just becomes 13.18, right? So we say roughly 13.18 years if they are looking for exact, as I mess up my cursive there, years. All right, and because I did all this writing, I'm going to take and I'm going to highlight it for my answer so it doesn't get lost. All right. Now looking at B, it says, under ideal conditions, a population of rabbits has an exponential growth, key term there, rate of 11.7% per day. Consider an initial population of 100 rabbits. They want us to first find the exponential growth function. Well, that's really simple. Exponential growth function, I have A equals PERT. So I have to fill it in. A equals, my starting value of P is 100 rabbits, so 100 times E raised to the power of R. Remember, we take that 11.7 and we convert it to 0.117, so raised to the power of 0.117. 0.117. And we don't know our time, so we're going to say t. Now, it says graph the function on the calculator. So we're going to do that. We're going to go into our calculator. We're going to go into y equals, clear it out, 100 times e, so that's second ln gives me e, raised is, it's already raises to the power of 0.117, and instead of t we use x, so just put 1.117x, close it out, and we're going to take a peek at it. Oops. Well, mine is not going to be on the screen because mine is adjusted. Remember, Zoom 6 resets your calculator. But again, because our starting value is 100, we're probably not going to see it. So I'm going to do something. You can do one of two things. We can change the window, or you can hit Zoom, go up to Fit, Zoom Fit, so that we can take a little peek at it. So it should change your graph so that you can see it. So technically, when it crosses the y-axis, that's my starting value of 100, and it just keeps going up exponentially. Now it says use your graphing calculator to after 7 days and after 2 weeks. Well, remember, we had a rate of 11.7 per day. So my equation is based on days. I can easily figure out day 7, but since it gives me 2 weeks, I need to convert that 2 weeks to days. So instead of looking at 2, I'm actually looking at 14 days. And again, nice and easy, I can go into my calculator. Oops. Go into my calculator, second table. There it goes. And I'm going to first look for 7. Oh, so at 7 days, oops, I get 226.82. I get 226.82, or roughly rounded up to 227 rabbits. And we're going to now look for 14 days. So I'm going to go arrow till I can get to the 14. And I get 578.34. 578.34. Come on, 578. Don't be funny. 578.34. Oh, there it goes. Okay, it's working again. 578.34, or roughly rounded to 578 rabbits. Now, it wants to know what is the doubling time. Well, the doubling time means how long does it take for you to get to 200 rabbits. So we want to know, where does it equal 200 rabbits? So 200 equals 100 times e raised to the power of 0.117 to the power of t. Okay. Or we can say the doubling time is 2 equals my exponential, 0.117 raised to the power of t. Now, again, there's 2 ways to go about it. We can take a peek into our calculator. So we go to go to our calculators, go to y equals, or actually we're in it, sorry. And we're looking for, where is my answer 200, or really close to 200. So I'm going to actually arrow backwards. Come on, work for me. Well, you're going to arrow backwards until you can see where you get an answer of 200. And if you arrow, it's between 5 and 6. So it's actually super duper 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 close. At 6, we get 201.78. So if we were estimating, I would estimate that it's really close, or approximately 6 days. But if you're calculating, you're going to take 2 equals e 0.117 t. And how do we get rid of an e but with an ln? So we'll take the ln of e 0.117 t. That ln and e cancel each other out. So they're gone. And it brings your 0.117 t down. So that you get ln equals e to the power, or not e, equals ln2 equals 0.117t. And to solve for t, you're going to divide by that 0.117 on both sides. And in your calculator, you will plug it in. So when you plug it in, you get an estimate of, well, t is approximately, because we're going to have to round, 5.92, which of course rounds to 6 days. So you can find it one of two ways. You can do it exactly or rounded, depending on what your instructor asks, if he wants you to estimate or if he wants you to be exact. Very important details.